Hello, my name is Anastasiya Konopitskaya, and I'm here with Coexist Build. It's a design build company out of Pennsylvania. However, we do work right now all over the country. So a little bit about myself. I went to school, I graduated in New York from Pratt Institute, practiced in New York for many years, then moved to Los Angeles, where I worked for many years, and then where I decided to start my own company. And the company was going to focus on residential construction, but more sustainable and healthy than what the conventional construction was offering at that time, which was just a few years ago, but it was a few years before hemp was legalized in the United States, which was a turning point in construction, the way I see it, or at least the potential. So today I would like to talk about the difference between conventional construction and hemp-based construction, which is something that's been that was initiated in Europe hundreds of years ago, but it came back to life about 40 years ago in France. The construction materials were very simple; they were very basic. It was what was available hundreds of years ago. That's been reintroduced now, basically as just hemp herd, lime binder, which is a natural mineral binder, and water, and that's all it is. And looking at that type of construction versus what's conventional here in the United States, and not just here, but in other countries as well, is exactly what I would like to talk about today. So this first image out of the plastic, this first image where it says out of the plastic box, it's a doll in a box. And so the ultimate goal of this conversation is to basically start thinking about who these plastic boxes that we're building for. Are they for humans, or are they for dolls who don't really get affected that much for environmental built environment? So I'd like to start with a few statistics first. These are statistics from the EPA website, and some of them are probably things that everyone already knows, and some of them are kind of surprising. So the energy consumption, 40% of the total US energy consumption are from built environment, where 50% goes to space heating. Surprisingly, the same percentage, 38.9% of the nation's total carbon dioxide emissions are also from the built environment. Our built environment, our homes, the number of homes is growing every year. 135 million residential housing buildings as of 2009, and that was 11 years ago. So it's growing exponentially, and it's growing not in the most sustainable sites also. A lot of them are coming up in desert areas of the US. What was interesting was that a lot of waste was, half of it was from demolition, some from renovation, and a little bit from new construction. What's interesting is that the EPA website actually specifically mentioned that architects and designers do not design for frequent demolitions or renovations of the buildings. But the good news is that about 20–30% of the debris actually gets recycled, and that's usually concrete, metal, and wood. So we're moving in the right direction. 160 million tons per year of waste. If we care about our environment and the earth and the place we live in, we should care about what goes on our landfills, because where we live is not always the healthiest. They're not always the healthiest conditions. But all that, we rarely think about these parts that go back into our environment and landfills, and they're still as toxic, and they will never decay. Most of them are built with petroleum-based products, so they will probably never decay. And so these piles grow and grow. Some numbers that are often talked about in hemp community right now is how much time we spent indoors, and it's 90%. It's shocking that we spend 90% or more of our time indoors, and indoor pollutants are 2 to 5 times higher than outdoors. The average family moves about every 10 years. So that's another number that I was surprised to read about, to consider when we design our buildings. Where does everything go? Because it does get renovated and removed and thrown away. But also it's the new materials that people get in their houses. So it's people paint about every 3 years. People buy new furniture a lot more often than every 10 years. So it's something important to think about. And of course, who gets the worst of it? It's our children. So many children now have asthma, and I was surprised to find out it's the most common serious chronic disease of childhood. The thing about this is that it is preventable only if we pay more attention to where we live and how we live and what we surround ourselves with. So what are those sources of indoor pollution? Combustion sources, building materials and furnishings. Not only that, though, it's household cleaning, maintenance, personal care, hobby products, central heating and cooling, humidification devices, outdoor sources, pesticides, radon, and generally air pollution. So now we're getting to the the actual house, the envelope of the building. What is it specifically? There were other items on that list, but since we're focusing on architecture, I will be focusing on building materials and furnishings. So if we look at the building envelope, what is it that we see if we cut a section through it, if we look inside? Excuse me. I will start with the structural members. Structural members, a lot of times it's just 2x4, 2x6. A lot of times it's treated if it's exposed to the exterior or if it's on the floor. But a lot of times it's also glue-line structural members, which are laminated, which means they're glued with glue that has formaldehyde in it. So eventually it's going to off-gas. From there, I'm going to look at the envelope from the outside into inside. On the outside, a lot of times, and of course, there's a huge variety of construction methods and buildings in the US. But what we see right now spreading like a suburban sprawl is a very common sight. We have asphalt shingles as the most affordable roofing material. Asphalt shingles is a petroleum-based product. On the exterior, it's vinyl siding or composite panels. Vinyl is a petroleum-based product. It's pretty much plastic. Next, after that, we see plywood or OSB sheathing. Plywood and OSB sheathing have formaldehyde in them. There is plywood right now available in Home Depot, actually, that does not have formaldehyde, but it's on the pricier end and it's used for furniture and not for exterior sheathing, not for structural sheathing. Then we have house wrap. House wrap such as Tyvek, we see it everywhere. We don't even really see any other alternatives. However, there are alternatives. For example, builder's paper. Builder's paper, which is a tar paper, it's been around for 100 years. It's proven itself. It works. It doesn't let the water penetrate your wall system, but it does allow the vapor permeability of the wall assembly. And I will explain why that's important, but that's a great alternative to house wrap. Also, it's a lot cheaper than Tyvek. Labor might add a little bit more to it, but overall it's basically paper and tar. Of course, tar is a petroleum-based product as well, but it is a better alternative because if it gets wet, it dries out and continues to function. Or Tyvek actually does stop performing that well after about 6 years. It starts tearing and disintegrating, especially if you have a wood facade like cedar. Then we're talking about insulation, which is the main topic of our discussion today. Insulation, the most common since 30s and 50s in the US. One of the greatest inventions here in the construction industry is pink insulation, which is actually called pink. Not just the color, but it's a fiberglass insulation that's itchy, it's unhealthy. You have to wear a Tyvek suit, you have to wear a respiration mask when you deal with it. I think we've all had contact with it. And the worst thing about it is that once it gets wet, it stops performing. So if any of you live in the northeast of the United States, which you probably do, If you have a stone building, for example, and you feel like it's cold and damp all the time, that's because your insulation most likely is wet. And when it's wet, it transmits temperature in general a lot easier. So if it's cold outside, it's going to be cold and damp inside. So that's that. And then you have to change it, but it rarely gets changed because how often do we open up our walls? Next, drywall. Drywall is not so bad in a cured condition when it's installed in your house, but it's not healthy for the environment and for people who make it. Paint. Just recently we have VOC paint on the market, but even still, not everyone gets it. Sometimes maybe it's not available in a particular color. So not everyone gets it, and yet we repaint our houses so often, every couple of years. Windows are vinyl. Decking outside is a lot of times people choose composite. Inside, engineered wood flooring. Showers and tubs, a lot of times made of plastic. Sinks in the bathrooms, you see sometimes they're composite. Formica countertops in the bathrooms and kitchens glued to the base. Particle board furniture is probably one of the worst offenders. And synthetic fibers all over the house, like curtains and even clothing. And when we surround ourselves with this kind of materials, honestly, there's nothing natural left in this house. We harm ourselves, the environment in the future when it's demolished, but also firefighters, someone we don't think about, but actually they're like canaries in the mine. Their brain cancer risks increased by a lot. I don't have an exact number with me, so I won't quote it, but it's been affecting them in the last 20 years. Their numbers of brain cancer have gone up significantly. And so really this system that was developed in the last 50 years in the US, it really works. Our homes are warm. It doesn't cost very much to heat them unless you use oil, like we do, which we're switching to gas. Not a good, it works great, but it's really expensive. Anyway, but the houses in general, they come with gas or electric, and they work great because this system is designed to create a great insulation. So it keeps hot or cold temperature on the outside and inside of the house the way it's supposed to. It seals against the moisture vapor and moisture in general, moisture vapor, so nothing gets through. Usually there are no cracks in this house, like in stone buildings. Of course, you have infiltrations here and there. It's usually at where the pipes infiltrate the ceiling, let's say, or walls, or at the electrical outlets. So you do get a little bit of infiltration, but not like people used to in stone buildings. And it's not that it was a great thing because it was drafting cold, but it provided a little bit of fresh air in the house. So what happens in our houses here, majority of the housing stock that's being built by developers, yes, it really does a great job at insulating while it's working, because really the quality of it depends on the craftsmanship of an installer. The same materials go in $1 million house and $100,000 house. It just depends on the craftsmanship. How well are the corners sealed? Where the plane changes the direction, wall to roof, is exactly where usually the leaks happen, here and at the ridge. So once that insulation, which is usually pink insulation, gets wet, as I mentioned, it stops performing. And so your house that was great the first 5-10 years, all of a sudden is not so comfortable anymore. But also there are off-gassing toxins that we don't feel. We can't put our finger on it. We can't put a number on it. How much does it hurt us? How much money do we pay in bills and doctor's visits and leave of absence at work when our children are sick? And so basically, so we went through this source. Yeah, okay. Boy. So this is the image I created where I was thinking, so, this system works. The system works great. It insulates. It does a great job. The bills are not so high to heat the house. So what seems to be the problem? And the problem is that overall health, higher profits that contractors and developers are seeking often result in low-cost materials, low-quality materials. That means high toxic content and VOC content, off-gassing, and unhealthy environment for us. In the environment, the depletion of natural resources and deforestation, and plus high carbon emission. And it's hard for us to think sometimes about the environment, right? Sometimes we want to make sure that we're healthy, and it's okay to think that. And that's why we're going to be talking about this next. But it's still important to mention about the environment. Okay, waste, lots of waste. And then high level of embodied energy, which is the energy it takes to actually create these materials. Okay, alternative. So now to the market came hemp. What does it mean for us? Hemp has been used in Europe for a long time now, successfully. Not so successfully at the beginning, maybe, but it was a trial and error. But now they know what they're doing, and they're sharing that knowledge with us. So it's finally here. It became legalized in November of 2018. And what it means for us is that we can build our homes out of plant-based materials that have no off-gassing and chemical-free. They can also help our farmers because the dairy industry that's in trouble can switch to this if there is a demand. Right now, there are some complications, some difficulties with this. There is not much demand because people don't know about this method of construction yet. So it's going to take a few years to catch up. Anyway, it's a regenerative material grown in the fields on demand. Requires very little water, no fertilizers. It removes pollutants from the soil and carbon from the air. It's really a magical plant. If the product out of hempcrete or hemp lime is prefabricated, then there is virtually no waste. However, waste is compostable. It's just lime and hemp. It will decompose in the field. In fact, sometimes farmers use lime to adjust their acidity levels. And efficiency. If it's factory built, you get same quality, same R value with same unit of insulation, and they're all cured to the correct water content. So you don't have to wait. Usually, the waiting time is 6 weeks. Okay, so what is hemp lime hempcrete? It was called hempcrete, but it's more correct to say hemp lime because there is no connection to concrete. Concrete is structural. Hempcrete, hemp lime is not. It's just insulation. It is a composite, biocomposite made of hemp hurd, which is a little particles of woody core that you see on this picture, and mineral lime binder and water. Lime binder is just basically lime, some pozolans to bind to hemp, and that's it. You just add water. So how does this work? The main principle behind hempcrete is the air bubble. So hempcrete, I'm so used to saying hempcrete, but it is hemp lime. It's air bubbles. It works exactly the same way as wool sweaters. We feel very comfortable in wool sweaters. If you run, it will help us control our body temperature. If we put synthetic on, we're going to sweat. It will be uncomfortable. We'll stop running, and then it's not good for anyone. It's just a little joke here, but yes, it will keep us warm with air pockets in between the hemp hurd, the wooden particles of hemp. Hempcrete provides R2 value per 1 inch of thickness of insulation if horizontally. If it gets installed too densely, the air bubbles get squashed, and the insulation, the R value goes down. So it's very important to know proper ways of installation and the pressure. The principle behind hemp lime assembly. So what it is it's a breathable envelope. It's a completely different assembly system in its root comparing to the conventional system here in the United States. What it does is it allows the moisture vapor to get into the building. So let's say it's best example is winter here in the Northeast. So it's wet and cold outside. It's hot on the inside because we're on a heater, and it's dry. So what it will do is it will absorb the moisture on the outside, and it will release that moisture on the inside. So it's a great humidity control tool. it provides excellent sound absorption, great acoustic qualities, and excellent thermal qualities. It also gives you a solid wall, solid monolithic wall with no cracks. So it's basically there's no air infiltration. Oh, I did forget to mention that in conventional system, when it's sealed so well, a house, and windows are never opened, it's encouraged to install AC, some kind of AC unit that circulates the air inside the house. So we even breathe recyclable or processed air in the house. With this system, it's encouraged to open the windows instead. And because this wall is partially masonry because of the lime binder, which gets stronger and stronger with every year, it has a thermal wall property, so it absorbs the heat and releases it at night, just like the moisture. And if you open the windows to refresh your air inside of the house, you can just close it, and you don't have to raise your temperature on thermostat to bring the heat up to your comfort level, because the walls will continue emitting this kind of warm temperature. And same goes in the summer; it will emit colder temperature, so it's very comfortable at night. Okay, so the difference between the two assemblies, on the left is a cavity wall, and as a matter of fact, you see that rodents can easily get in. It's just a joke of our slide, but it does reflect the reality. When you open up a wall, you find a lot of nuts and nests of all sorts. Where with this wall, it's actually pest resistant. Pests cannot get inside because lime is acidic and it will kill animals. It will not kill the squirrels though, because we tested, they will eat through that too. Okay, so the idea here is that the structure, which is, if you see on the right-hand side, the runners and then studs, they get embedded in this wall, so it also eliminates thermal bridging, which is another important part of this, because in the conventional construction, our wood structure connects exterior to interior directly. So if we touch drywall, a lot of times it's really cold. So, but with this system here on the right, hempcrete, its basic elements is hempcrete or hemp lime and plaster on the inside and outside. Basically, we eliminate all these components that traditional, conventional, I shouldn't say traditional, conventional construction right now has, which is vinyl facade, Tyvek, plywood on the exterior, pink insulation, all these different elements, drywall, paint, so you have to mud it first, right? Then paint, and then finish carpentry. For molding, with hempcrete, you don't even need to have molding. You can just kind of wrap it around your windows. So you can eliminate all kinds of trades, which is why, in a way, it's a little bit difficult to calculate the price of the system in comparison to the conventional system, because you eliminate so many trades. But in general, it's about 20 to 30% more expensive. Okay, I'm sorry, I keep making a mistake with a wheel. Okay, so what benefits does it have in terms of health? No off-gassing, low VOC, non-toxic, free of allergens, because hemp does not use fertilizers. It actually removes fertilizers from the ground, which is why we should be careful about sourcing our CBD oil. If we don't know where it's coming from, if the field were not organic for the last so many years, you might be injecting some kind of substances. Made from natural, renewable raw material, it can be grown. It grows like weed. That's why it's called weed. Another word for it. It regulates temperature and humidity. It's breathable. It replaces layers of petroleum-based products. Pest resistant, mold resistant, because again, lime acidity does not allow mold to grow, which is great. What happens in the conventional construction is if you turn off your AC in a humid environment, you will grow mold very shortly, within a couple of months, inside of your walls. This wall does not do that because it dries out. Constantly goes through that process of getting wet and drying out. Natural process. There were tests done actually. The hempcrete cures completely before plaster is applied. There is no mold growth. If it doesn't cure completely, there's a little bit of mold growth on the plaster, but then it goes away. Thermal mass, which is what we talked about, vapor permeable envelope. It can be used for the floor, wall, and ceiling. So if you use it for the entire envelope, it will give you a completely monolithic envelope that's vapor permeable. So you it will block the air, so you will not get any kind of infiltration, but it will help you control the temperature and humidity. And overall, it promotes healthy living. Hemp actually smells like straw. And I have another product here with me that I'd like to show you and smell it for you. Okay. It's sustainability. So it's biodegradable. I can throw it in the field and it will degrade. Sustainable, zero carbon footprint. Unless you use you prefabricate it at the factory, then there is a little bit of carbon footprint. Sequesters CO2, replaces layers of petroleum-based products. We talked about it. It's durable. It's fireproof. There was testing done for flammability and smokability. On a scale from 0 to 400, it was a 0, which is incredible. Self-build friendly. People can do it themselves. There are workshops everywhere. Well, I'm not going to say everywhere, but in a lot of places. Here in the PA, they were held a few times. In Colorado, we were going to hold 10 workshops this year. Unfortunately, because of COVID, we canceled them. But I will later elaborate on what projects we have and what we're going to have next year. It's lightweight when it's cured. If it's not lightweight, if it's heavy, that means the moisture is not out of it didn't dry out yet. It's easy installation. If you do it, there are 3 ways to install it. One way is tempering it in by hand, which is what you see on this picture. You use a tool, or you can use a hand, and you basically pour it in your cavity. You do need shuttering, which is a formwork. Another word for formwork. You put up a formwork, you put it in, you temper it in the way you need to do that in a specific way, and then you immediately lift up the formwork and move it up high. Just a second. And basically, so you have formwork, you remove it, you put it up, up, up as you go. Okay, so 1 second. Okay, 1 second. Oh, yeah. Okay. Prefabricated option. There is now available prefabricated option in the United States, and as our company, we're the only ones in the US right now making blocks. Right now, they're made in Europe in 2 places, in Italy and Belgium. And if we care about the environment, we don't want to ship them here by ship, actually, by boat. It will increase our carbon footprint. So we found a way to make it here. We're making it. We're using, we source our hemp from Europe, unfortunately. But once there is a demand, we will be working with the farmers. We have a number of farmers interested, and we're located in Pennsylvania. We're surrounded by farms. The blocks are the same size as the CMU block, so it's familiar to masons. Very easy installation. There is a fire testing for it. And hopefully it can be bought and sold in places like Home Depot. So it's accessible to everyone, not just the lucky 1%, let's say. Okay, so this is a place where we make it. So we had a few orders already shipped out. We started last year. We're building our first building with it right now. We have a project called Experimental Hemp Village. So we can produce up to 3,000 blocks per day. It all depends on the demand. Third type of application is called spray-on easy application. It's a machine that was designed in France. You use a specific binder and hemp, a binder that was designed for this machine that's also imported from France, and you pour it in. And what we just discovered, this is Cameron McIntosh of Emery Chanvre. We work together frequently on the projects, and what we discovered is that hemp block and spray-on work beautifully together when hemp block can be installed on the inside as a formwork. So we install it inside, we secure it, and then he puts a mesh and sprays it on the outside. And so while it's drying on the outside, the interior can be already finished with plaster or anything else. And by anything else, it's really not anything else. There are constraints. I'll get to it. And this is another product that I wanted to mention. This is a hemp bat insulation. It's a great replacement for fiberglass pink insulation. Basically, it comes in 16-inch and 24-inch widths by 4 feet high. It's a great material to replace pink insulation, and goes into our conventional cavity structural system. It fits in perfectly. You don't need any hazmat. It's actually it smells like straw. I will show you right now. You can actually see it behind me, but this piece just fell here. I will show you how to handle it, just like that, without gloves. It smells amazing. It's just a beautiful product. It's hard. It's very hard to push it. It almost feels like horsehair furniture that used to be made with horsehair a long time ago. It almost feels like that, but you can't really sit on it for a very long time. It will depress and might not retract back. So this material here uses no glue, no formaldehyde. If you're familiar with rock wool rocked the world when it came out, because it was a great replacement for fiberglass. Unfortunately, fiber uses formaldehyde. I don't want to disappoint anyone, but it is true. It's not something they advertise, but they use. I called them, spoke on the with the customer service, and they said yes, we use it, but very little. But it is still there. So we have to be mindful about what we're using if we're trying to get away from those kind of toxic chemicals. This system here, this insulation, uses 8% of polyester to bind hemp fibers together. And by the way, it uses different part of the stalk. It uses the fibers, where the block uses the woody stalk, woody core of the plant. Two different materials. So great material. We distribute it, so if anyone is interested, we can provide more information and spec sheets. Let me see if I didn't miss anything. Okay. Okay. No guessing, nothing, no allergens, nothing like that. Renewable raw materials, again, breathable, works the same way as hemp lime. It's a breathable wall construction, and if it gets wet, it continues to perform, which is important distinction between this and fiberglass insulation. If it gets wet, if it can breathe, if other materials allow it to breathe, it will dry out and will continue functioning. So you don't need to replace it. So if upfront costs are a little bit higher, you kind of save it in the long run. It's always a hard sell, but keeping in mind that it's also overall a great material, it might help. It's actually it can be compared really to fiberglass. It's a next level. It can be compared to rock wool, but it's still at the next level from that as well. It promotes healthy living overall. It's just a great product. We're actually installing it right now in one of our projects. Okay, so it has different thicknesses. We have R13, R20, and R28. For the ceiling, you have to double it up if you want R40 or R39. And this is how it goes in by the spring action. It just needs to be just a little bit wider. It doesn't have a paper backing, just a little bit wider than the opening between the 16-inch or 24-inch on center. And you just push it in and it stays in. These are a couple of details here. The reason I want to talk about this is because some people maybe don't want to install plaster on the exterior and interior. Are there other options? Yes, there are other options. If you have your stud wall exposed, like in both cases here, for example, usually the stud wall gets embedded in hempcrete, and so if you would like that kind of system, you really should coordinate your details, because your studs will be pushed in a little bit away from the edge of the concrete or whatever floor system you're using. So in this system here, so if the stud wall is flush with insulation on the exterior, you can use builder's paper runners or furring strips and some kind of other system, whatever you desire. If you don't provide that airspace, actually it's always desirable, so it's like a rain screen. If you don't provide it, the material needs to be breathable. So wood, masonry, or plaster. On the inside, if you can nail it, if your block wall, if your stud wall is flush with insulation on the inside, you can attach magnesium oxide board, which is a great substitute for drywall. Not easy to work with, but is a great material, healthy alternative. Not every brand though. There are these things, of course, that are not everything great is kind of easy to kind of put together, but we help with that kind of process. Anyway, so you can either use plaster, or you can use drywall too. Drywall actually is breathable, or magnesium oxide board. But you have to make sure that you paint with something that's breathable. You can't use paint from Home Depot, let's say latex or acrylic. You have to use, so what we're going to use is in our projects is we basically use tech coat, which is a form of plaster with recycled glass in it that gets stuck or it stays on drywall, and then you can paint it with lime paint, or you can finish it with plaster, and overall you get a earthy, much healthier, more pleasant looking, aesthetically pleasant finish on the inside, and it doesn't take much more labor, or it doesn't cost that much more. Okay, so in these two details here, I just wanted to touch base, just checking my time here. Okay, I wanted to touch base that on the one other thing, you can combine different methods of insulation. So on the left, I'm showing blocks on the interior and spray on the exterior. Blocks can't really go between the studs, unfortunately, because the studs can never be precise to eliminate any kind of air infiltration gaps. So the blocks, to create monolithic surface, they need to go on the inside or outside, and then in the cavity wall, you either temper it in by hand, which is always an option. Always, DIY aspect is really nice. People do it all the time. A lot of people do it. Or you can spray on, or you can put bed insulation, which is also great because you don't need to wait for it to dry. It takes about 6 weeks to dry for hempcrete or hemp lime. So on the right here, I'm showing this detail. It's basically rain screen system on the exterior, hemp bed, then block on the exterior. Overall, it will give you about, so let's say 13 plus about 20 or 20 if you use a 4-inch block. And then the finishes on the interior that I was talking about. It does need precaution if you're laying it on a concrete slab, slab on grate especially. You need to protect it from the moisture seeping up from below. Okay, has it been used? Yes, in Europe it's been used extensively, in France, England, Belgium. In the US, we're slow to catch up, but we have about 40-50 buildings. The first one was built in Asheville, North Carolina. You can see it in the upper left corner. That made a big splash, and after that, the Highland House followed. I think that's in Washington State. And then there were many more others, but I wanted to show a picture of this one that also made a big splash. The one on below, it's in England, and it's it was done by Margent Farm. The panels on the outside are also made out of hemp fibers, and then interior, you see they finished it with a clay on the interior, so you see the particles and everything, but it's solid. It's not going to fall down. Usually, you have to finish it with plaster, but clay is also can be used. Okay, this is something we built last year, and we made a debut in Javits Center in New York, and actually in Design Philadelphia last year. After 3,000 miles, we've been to Chicago. We've been all over the Northeast with this house on wheels. It's a great demonstration that we could bring with us to people rather than for people waiting for people to come to us. After 3,000 miles, it still looks brand new. And this is our project that we're working on right now. It's called the Experimental Hemp Village, and we have 6 projects going on right now. So we have the summer kitchen, which is completely restored. We used hemp fibers as instead of horsehair in the plaster. Then summer pavilion, which will be coming up next year. the guest house, which we're building right now. Actually, I was going to do this presentation there, but we have roofers building the roof and installing the hemp bed, which is a better use. We found that it's easier to use that in the roof than hempcrete. Hempcrete is just a little bit trickier. You need more formwork there since it's a ceiling. So we decided to just use lightweight hemp bed since it goes so nicely in a regular 24-inch wide cavity. The office will be next year, and we'll be holding workshops to install, to do the office, and we'll be probably using blocks. The residence, we're doing an addition next year. We're going to do it this year, but unfortunately with COVID, we had to cancel some of our plans. And then the pool house is nearly complete. There are some finishing touches. So we have 2 completed projects. 1 in progress will be done this year, and then 3 will be starting next year, and we'll be holding workshops. Oops. Okay, so this is the pool house. This is we did temperate in place. So we did formwork. As you can see, the shuttering is still there. You can see it. So as we were building, we were just going up, and this was done in, I think, about 2 days. We'll be using cedar on the exterior with the air gap in between and plaster underneath the canopy. Okay. This is a guest house that's in construction right now. We're putting a hemp bed on the roof, and inside, I didn't have a good photo, but inside is hempcrete is there. It's installed. Now we're doing plastering. And this is a summer kitchen where we used hemp fibers instead of the horsehair to reinforce the oven. It's a 200-year-old summer kitchen that collapsed, I don't know, some time ago, 30 years ago maybe. And we were working with local Mennonites who knew exactly how to build it, because they know from generation to generation, they know how to do this. And so they built it, and because hemp lime has fireproofing properties and insulating, we decided to use that on the exterior also to keep the temperature more stable on the inside, but also in case there's a fire that breaks out, maybe perhaps it can slow it down a little bit. So that's it. These are our projects, and I just want to go back to my first slide. Why did I pick that photo? Okay, the doll in the plastic box. We see this, we buy them, but they're dolls and they don't need breathing, they don't need eating. They're okay there in that box, they're okay. But we are human beings, and do we do just as well as a doll in a plastic box, or do we as humans need and deserve and should demand better conditions? We strongly believe in this this kind of system. This is what makes us get out of bed every day. We're hoping to make a difference and create a mini revolution in the United States by introducing and creating as many examples as possible of hemp lime buildings in the US, so it becomes, and creating a more streamlined process of installation, so it becomes more accessible to everyone, and not just the lucky people who can afford. Hempcrete is hemp lime, and hemp bed are a little bit more expensive, as I mentioned. But in the long run, if we can eliminate asthma and all these other health problems and lower cancer rates, and then I think it's worth going for, worth trying. So that's it. I'm trying to think if I missed anything. Just a second. I have 3 more minutes. Well, a little bit more about ourselves. We're corporate sponsors and members of US Hemp Building Association. And we're on a committee of the local, altogether now, local supply and demand committee, spearheaded by Judy Weeks. So we're working to create local supply and demand here in Pennsylvania. We have factories and we have farmers. We have everything that we need to start this going to go full speed. Now we just need demand, and that it's a kind of what comes first, demand or local supply? Because if we can't, if we have to ship it from Europe, then the prices are high, then demand is low. So this is something we're working on with Judy Weeks and a lot of other people who are in the same hemp committee and other companies, organizations throughout the US.